Good afternoon. My name is Bryant Baker. I am the Director of Conservation and Research at Los Padres ForestWatch. I am so happy that you all are here today to hear a little bit about our concerns over this really large project that has just been proposed in the Los Padres National Forest. For any of you who are not familiar with our organization, we are a nonprofit conservation organization that is based in Santa Barbara. We work to protect the Los Padres National Forest, the Carrizo Plain National Monument, and some other public lands throughout the region. One of the big things that we work on, and we have been working on for many, many years, uh, is is wildfire related issues. And obviously, wildfire is a pretty large, pretty big part of our lives here on the Central Coast. Most people who live here have probably experienced a wildfire in one way or another. Maybe you've had to be evacuated. Maybe you've, unfortunately lost your home to a wildfire. Maybe you've just, driven by one. Or maybe you've experienced the smoke. We tend to um, have wildfires in the region each year. And it is a very important issue in terms of how do we actually protect communities from wildfire, and also how do we protect the natural resources in the Los Padres National Forest. So I'm gonna really go over this. I'm gonna try to get into some detail on this project, but I gotta say, it is the largest project we've ever dealt with. It honestly feels overwhelming. It was proposed a couple of weeks ago, and every single day, it just it sinks in a little bit more just how big this thing is. And when I was putting this presentation together, it felt overwhelming to put this together. I'm really only going to scratch the surface. There are entire ecosystems I'm not even going to be able to really talk about just for the sake of time. And I have a lot that I want to get through. So we'll get started. Again, if you want to ask questions, the best way to do that is to uh, send questions through the Q&A function, but you can also put questions in the chat if you'd like. All right, I'm going to share my screen, and we will have a Q&A session at the end. And at that point, we can go, like, we can get really specific and look at specific areas together. Okay, so uh, 235,000 acres on the chopping block. I know that sounds a little bit sounds a little out there, but this is what we're actually dealing with right now. And it's this project that the Forest Service has called the Ecological Restoration Project. We're not we don't really agree with the name, and maybe you'll understand why by the end of this. But in summary, it is a 235,000 acre project in total, and it's split up into two different project areas. And so there are 48,000 acres of what they're calling forest health treatment units, and then there are 186,000 acres of fuel break and defense zones. So if you've been following our work for the last several years, if you've been staying up to date with what's going on in the Los Padres National Forest, you're probably familiar with some relatively recent projects that have been proposed and or approved that involve some sort of vegetation removal. In the eastern Los Padres National Forest, what we've seen are the Takuya Ridge project, the Cuddy Valley project, the Pine Mountain project. All of those have been approved by the Forest Service using what are called categorical exclusions. They've really skirted the NEPA process for those to a large extent. But there's also the Mount Pinos project that hasn't been approved yet, but it has been proposed, very similar to these other projects. And some of these we've litigated. We're actually in court right now over the Pine Mountain and Takuya Ridge projects. There was also a project. Now these are all mostly in forested areas, so they have a big logging component to them. There was also one that we didn't really we didn't litigate. We didn't fight too terribly hard. We did try to get some better mitigation measures put in place. But this was the Monterey. I forget what the exact name of it was, but it was a fuel break project up in the Monterey Ranger District. And this is how you're going to see several maps today. This is the southern Los Padres. This is the Monterey Ranger District, the Big Sur area that's up north. So this is, I just can't, it's not easy to show it all on one map. These are at the same scale. So it should all be, the size should make sense, hopefully. But there was this Monterey fuel break project that was approved. This was back in 2018, I want to say. And this is like, these are the biggest projects really that we've dealt with of this kind just in the last 5 or 6 years. Okay, so everybody sees this map. Now, this is what we're dealing with the ecological restoration project, as it's called. All of this yellow and brown, those are part of the project area. So I know I said earlier 235,000 acres, and if you know what an acre is, you know that 235,000 of them is a lot. But a lot of people don't know what an acre is, and it might just be easier to see it on a map. And maybe this gives you a sense of just how widespread this project is. So it stretches, it's kind of scattered across the landscape, but it stretches all the way from the eastern edge of the Los Padres National Forest up here in southern Kern County up by Fraser Park, all the way up to San Luis Obispo, up to West Cuesta Ridge here, Cerro Alto, and then also throughout the Big Sur area, the Monterey Ranger District. You'll notice that it avoids currently designated wilderness areas. There's some reasons for that. It's just a little bit harder to get projects approved in wilderness areas. And we're glad that the Forest Service isn't proposing to do things there. But I will talk about all of the places that this project is being proposed in that we are quite concerned about. So again, just take a look at this map. Again, the brown is those are the forest health treatment units, and then the yellow areas, those are the fuel breaks and defense zones. So what does any of this mean? What are they actually proposing? So the 48,000 acres of what are called the forest health treatment units, those are where they're going to do some sort of tree thinning, and they have a 24-inch diameter limit in those areas. So trees up to this size that you see here, this is me for scale. This is about 23.5 inches. This is on Pine Mountain. You may have seen this photo before. I took this back when we were working on public outreach about the Pine Mountain project. We're seeing in these forest health treatment units, the language is very vague. And I should maybe start off with saying that we're just going by what is in the proposal document, and the proposal document is 17 pages long, and it's not super detailed, but this is the information that we have to work with right now. And so what the Forest Service is saying is that they will remove trees and shrubs using mechanical or hand cutting methods. Mechanical, that can mean heavy equipment. They're also talking about mowing, masticating. I'll show you what mastication looks like here in a second, chipping, and then pile burning. The Forest Service has pitched this to the public in their press release, and in the way they've been talking with reporters, that this is a big prescribed fire project. I am not seeing that in their proposal. It is mostly focused on mechanical vegetation removal. So I don't know where this idea that this is all about prescribed fire is coming from. 186,000 acres of it are fuel breaks, where this is not really about prescribed fire. So don't think of it that way, because when you actually look at what they've written and look at where they're proposing these activities, it's really easy to see that this is about mechanical removal more than anything else. So in these forest health treatment units, to give you a sense of what they could look like, this is what we see in practice in national forest across California. And I'm going to show you a couple of photos also from Eastern Oregon as well. But this is one that I show a lot because I just happened to find a satellite image that was taken during the project implementation. So this is the Plumas National Forest. This is an area that actually just burned in the Dixie Fire last year. I don't have any post-fire images of that, but this is before the fire. This is before the thinning treatment as well. So this is 2014, very open Ponderosa pine forest here. I'm not sure why this was targeted for, opening the forest even more. It was already very open based on what I'm seeing. And you got to think, you're seeing a lot of these are shadows that the trees are casting. So there's not a lot of trees here to begin with. And they approved a project very similar to the Pine Mountain project that was proposed back in 2020 that we're currently in court over. It did have a 30-inch tree diameter limit, I want to say, in this project area, but same methods, same reasoning, mostly the same language. Here is what it looked like during the project implementation. So what you're seeing here is these are what we call skid trails. This is from heavy equipment that is moving back and forth on the landscape. What they're doing is mostly transferring cut trees back to these landings. These are like little areas that they set up where they're going to stack or deck the logs here. And this is also where these trees get limbed up. They cut off the tops here, and those get sort of put into slash piles. And these logs, I think I have some other images I'm not going to show today, but you can actually see the logging trucks. And some of them were getting just chipped and turned into like wood pellets or something to probably for a biomass facility. But this is a pretty serious commercial thinning operation, and you can see there's been a lot of damage on the landscape here, and it opened up the forest just to a ridiculous extent. I mean, this is just incredibly open now, but it was already really open before. This is a non-commercial thinning operation that has been taking place for a long time on Figueroa Mountain. So when I say non-commercial, that means, for the most part, it means that there wasn't some timber sale involved, but it can also be indicative of the size of trees that were actually being removed. Some of these look pretty large. They look larger than I would expect for this project area based on what was approved there. And I can't remember exactly what the diameter limit, but it was a lot lower than 24 inches. Some of these could have been dead trees before they did this cutting. And so there's a lot of leeway that the Forest Service gets when they're cutting dead trees. But you can see there's a lot of slash piles, a lot of, log material here, a lot of, wood chips and sawdust. And this was like this for quite some time, where it was just really messy up here. And so I think people forget that these projects, they take a while to implement. And during that time, this is often what they look like. And you can see an increased risk of an increased fire hazard during these periods when there's all this slash on the ground. Same with, this is another non-commercial thinning operation up on Cerro Noroeste in the Los Padres. I took this last year, I want to say. And all of this slash was, I think it was on the ground for most of the fire season. And these were smaller trees. I think these were probably 8-inch trees mostly that were being removed. And so you got to think most of these other trees here would fall into the category that could be removed under the currently proposed project, because remember, in these 48,000 acres of forest health treatment units, they can remove up to 24-inch diameter trees, which would probably be close to like what that tree is right there. Here's some photos that I did not take, but are from some colleagues of mine that are showing intensive commercial thinning operations up in Northern California and Eastern Oregon. And there are a lot of photos like this. These are probably not even the worst examples. And the reason I'm showing you this is because I think people have this tendency when they hear thinning, and especially when the Forest Service is talking about it, it sounds like they're just going to go in and remove some saplings and really small trees, like maybe they'll do some pruning. But a lot of these projects are these commercial thinning operations, and they include very large trees being removed, and a lot more than you would expect. So as you can see here, here's another one. This is Eastern Oregon. I think all the logs have been removed, all the actual trees, but here are the slash piles. And if you look really closely, you can see them just stretching all the way back here. So they've really opened this area up. This is what we see often, and who knows how long these slash piles end up sitting on the ground in some of these places. This is another one. This is, I believe, somewhere in the northern Sierra Nevada. Another pretty large trees being removed. You can still see the blue paint on some of these stumps, and a lot of slash still left on the ground. And what you'll notice in these photos, a lot of them, is there's not a whole lot of understory activity going on here. There's not, they get rid of all the shrubs usually. There's not a lot of small trees. There's just not much going on in these areas. And they will often they'll come back in and do this again in 7 to 10 years. And it just doesn't give some plants a chance to reestablish in the understory. Here's another one. I think this is possibly from the same operation in the photo I just showed you. This is taken by the same person. And this is, again, another thinning operation. This is labeled as a thinning project. That's a massive slash pile back there. And these are really large trees that are being removed. So I don't think what is happening on the ground is always what is happening in people's minds when they think of thinning. Okay, so and I'm gonna talk more about all that type of stuff here in just a bit, but I want to explain these fuel break and defense zones as well, because this is the sort of meat of the project. It's 186,000 acres. Uh, it's just every time I think about these numbers, they're just really, really. This is a lot of land. This is a lot of acreage. Here, if there are trees, and the fuel breaks can occur in forested areas, they can occur in chaparral, they can occur anywhere basically. But in these fuel breaks, any tree, any size, any age, any species, they can be removed. And the Forest Service is saying that they will retain some trees, but they're not giving us much information yet. Hopefully, we'll get more information down the road. But we're seeing some really, dangerous language here, which is trees of any size can be removed, and basically any amount of trees can be removed. And you can see there's a long list of all the different things that can happen in across these 186,000 acres, including mechanical thinning, cutting, mastication, lots of heavy equipment use, but even things like grazing and mowing and weed whipping, just all sorts of different activities would be covered under this project. This is what a masticator looks like. This is important to understand this process, because I think this is probably what would be the majority of activity in the chaparral portions of this project, especially. And so, let's see here. So what you're seeing is just, yeah, big piece of heavy equipment. It's got this gnarly thing on the end that just grinds shrubs down from the top, and it turns them into mulch basically. And that's what you're seeing here. This was all native vegetation behind here that's being, it's just being grinded up basically. And Jeff, our executive director, he took this photo. This is in the Camino Cielo fuel break. I don't know how many years ago this was. And I think that I don't know if that shrub was going to get left or not, but I have a feeling it wasn't. So that's what mastication looks like, and that can be allowed in both the forest health treatment units and the fuel break areas as well. Okay, so here's another, and if you catch me looking, I'm just keeping an eye on the chat and in the Q&A, just in case anyone has any questions pertinent to what I'm talking about right now. So this is another fuel break, and you're going to see a lot of images. I'm just trying to show you examples because I want people to come away from this understanding what could actually happen on the ground, because a lot of the language sounds good. It's kind of this rosy, a lot of euphemisms, but it's really important to see what it means in practice. This is a big fuel break, very created using the same exact methods that are in this project. This was down in the Cleveland National Forest earlier this year. I don't think that this was created with mastication. And if you look closely, you can see all these piles. And this is a sort of a close-up area, and I walked all through this, and it's pretty depressing because look, this is the mature chaparral up here, a lot of chamise, a lot of ceanothus. You can even see some of the ceanothus is blooming up there, and it looks like this was mostly hand cut, I think, and then piled, and who knows when it'll be burned. And there's just what's going to come up in place. This is in the winter, so we hadn't quite gotten to the season where we would see the non-natives drying out when they're really easy to see. But what we tend to see is that these areas become very dominated by non-native invasive grasses and weeds. And that's what you see here. This is a much older fuel break that's been around since the 70s. This is the Camino Cielo fuel break along West Camino Cielo. So if you're familiar with the West Camino Cielo area near Santa Barbara, Lizard's Mouth and Winchester Canyon Gun Club are behind me basically. And I'm looking out along the crest of the San Ynez Mountains. Up there is San Ynez Peak, Broadcast Peak. And so this is a very wide fuel break. This has been type converted. This is what we call this process where one ecosystem or vegetation type gets converted to another. And here, this was converted from chaparral to this non-native, mostly a single species, wild oats. It's this non-native grass that is, you can actually see it right here in the foreground. And this is highly flammable. It's an annual grass. It doesn't do much in terms of erosion control, and it dries out really early in the year and ignites very easily. And you often see these fuel breaks are along roads, and that's where we tend to see ignitions occur. We also see ignitions occur under power lines, as you might imagine. And so when we see power lines crossing these really, these areas with a lot of non-native flashy fuels, as you might call them, that is concerning, of course. But we often see that the fires in the San Ynez Mountains, they actually start in these fuel break areas and then move into these areas that are dominated by native species in Chaparral here. Okay, so again, it feels overwhelming, and I feel like I'm just not I'm not going to be able to cover everything, and it really is just scratching the surface. But just to give you a sense of like the number of trails that are within this project area, this is just a handful of them. So these are entirely within the project area, and I'll give you a second to just kind of look through that list. You might see some that are familiar. One of the very first trails that I hiked on when I moved to the area was the Davy Brown Trail. Um, if you've been on it, you know it's an amazing place. Lovely big cone Douglas fir stand, entirely within the project area. All 100% of the trail is within the project area. And there are a lot of trails, a much longer list than this. These are just some that I pulled. That at least 20% of the trail is within the project area. So this is that area. This is Davy Brown here, and this is a good example of, I think, how like entire areas are being targeted as part of this project. So if you're familiar with the Figueroa Mountain area or you've been to Grass Mountain, most of this that you can go and recreate in is included within within the area. And I noticed someone asking about Tunnel Trail. Uh, a lot of Tunnel Trail is actually on I think it's on city land. It's not federal, which is a little confusing, but I think the portion that is on public federal land in the Los Padres, I think it is included. And what we can do at the end is we can actually go onto our interactive map, which I'll post a link here in a bit, and we can look at it together. And if you have questions about specific places, we can go look at those. But again, if you're familiar with the White Rock area, Sunset Valley Trail, Munch Canyon Trail, Davy Brown Trail, this is Willow Springs Trail here, La Jolla Trail, most of those trails are within the project area. And what's really wild to me is that a lot of this is this forest health treatment unit. And most of this area is not even like forested. It's mostly chaparral down here. There's definitely some like valley oak woodland here. It's pretty open in my opinion, but up here it's all big cone Douglas fir. We've never seen big cone Douglas fir targeted as part of these types of projects. It's kind of its own beast. It's got a really unique relationship with wildfire, and I can talk more about that later. But yeah, and thanks, Ray. I see you talking about Tunnel Trail. The upper part is private. That's right. It's got an easement. So yeah, it's just whole areas like this. Another one that I'm going to have a map of at some point, not in this presentation, but that'll be just like this, is the West Cuesta Ridge area. So if anyone is up in the SLO area, it looks just like this. The entire West Cuesta Ridge is included in the project area, which is just very surprising to me. But here's just some photos I've taken of these places. This is Sunset Valley Trail while the ceanothus is blooming in the winter. This is big cone Douglas firs along Davy Brown Trail here in Fir Canyon. The summit of Mount Pinos or Iwa Hinmu'u is included, which is just bizarre. And sometimes I feel like Jeff, our executive director, and I keep using this term mind-boggling, and I can't help but use it here. I mean, some of the stuff is mind-boggling, and I don't understand it, but it's included in the project area. This is Apache Canyon. A lot of that is included in the project area. This is East Cuesta Ridge. This is Highway 101 over here. I think this is East Cuesta. This actually, now that I'm looking at it, this might be West Cuesta Ridge. Maybe I'm looking at the backside. Both of them. East Cuesta, part of East Cuesta is included. All of West Cuesta is. It's just, again, it's mind-boggling. And then I'm going to get into some more mind-boggling statistics. I could show you photos for days, but let's just get into some numbers. 56,000 acres of the project area overlaps critically or federally designated critical habitat for threatened and endangered species. A lot of that is for the California red-legged frog. That's this little guy here that I found along, I don't remember where, I think maybe the Manzana Creek, actually. Um, that's a lot of critical habitat. We, we are not used to seeing projects have this much federally designated critical habitat for federally threatened and endangered species. This is pretty alarming to see this much potential habitat being impacted here. If you've heard of the Central Coast Heritage Protection Act, um, that is a huge bill that we've been working on with a bunch of different partners, California Wilderness Coalition, Sierra Club, the Wilderness Society, Pew Charitable Trust, a lot of different groups, and I should probably name a lot more. But we've been working on this for like over a decade. And for the last couple of years in a row, it's actually passed the House of Representatives, and it just passed recently in the House and is awaiting a vote in the Senate. But 35,000 acres of that, of the areas that would be designated as new wilderness or national scenic areas are included in the project area, including this area back here. This would be part of the Chumash Wilderness if this bill goes through, and this is in the project area as well. 104,000 acres of inventoried roadless areas. These are special areas that are often what can become wilderness later. So there's a lot of overlap between these 35,000 acres and these one. In fact, probably all 35,000 acres of the Central Coast Heritage Protection Act are also inventoried roadless areas, but there's a lot more inventoried roadless area that that would be affected as well, including this area. This is over by Thorn Meadows Campground, if I remember correctly. These are a bunch of sugar pines in the project area, also in an inventoried roadless area. Okay, so I've given you some numbers, I've given you some stats, you've seen some maps, and we'll see some more. But one of the things I want to address is just this concept that the Los Padres National Forest is A, like really forested, and B, it is the forested areas just haven't burned in like a century, and they're extremely dense, overgrown. And if the Forest Service doesn't go and do this work, that it will, these forests will burn, and they'll burn at high severity, and then they'll never grow back. So I'm gonna try to address all that, and there's a lot to this. But here's an area. This is in the Chumash Wilderness. This is this is somewhere around Lily Meadows, if you guys are familiar with that area. But if you've ever been in the Chumash Wilderness, especially at lower to mid elevations on that south-facing slope of the of Mount Pinos and Sawmill Mountain and Cerro Noroeste, in the Jeffrey and Ponderosa pine dominated areas, so the yellow pine and some mixed conifer forest. I'm not talking about the pinyon juniper woodland areas. Those are different, and they have a different natural history and fire regime. But in these areas, which is what the Forest Service is really talking about when they talk about forest health, they're talking about Jeffrey pine forest and mixed conifers. This is what it looks like. And I have to tell you, this area, this is what most of this area looks like. It has no recorded fire history, and it has no modern management history. So you would think, based on those two things, that what you're seeing here should be way denser, should be really overgrown seemingly, right? But it's really open, and that's because there is natural heterogeneity on the landscape. There is a lot of diversity in terms of forest conditions, forest structure, and that's a good thing. We like to see open forests. We also like to see areas that are denser because they support different types of plants and wildlife. And I can show you a lot of photos that look just like this, where you have areas that have no recorded fire history and no modern or recorded management history, and they're very open, mixed conifer, ponderosa, Jeffrey pine forest. Here, this was on Pine Mountain in the Sespe Wilderness. This is on Cerro Noroeste. This is not, I don't think this is wilderness, designated wilderness. And yeah, this is mostly Jeffrey pine, maybe some white fir. I don't see any. So yeah, it's mostly Jeffrey pine here, very open. And this is how a lot of that mountainside looks. And it's not like there's been thinning in here. There hasn't been recent fire. There hasn't been prescribed burning. And it's still very open. This is Mount Pinos. This is how most of Mount Pinos looks. There are definitely areas that are denser than some, than other areas. But again, we like to see heterogeneity on the landscape. We like to see that sort of patchiness in terms of density and open forest conditions. And one of the things that I think the Forest Service really tries to convey to people that I think is incorrect is that open forest is sort of like an insurance policy against natural disturbances and tree mortality. And I can find you plenty of places that are really open and they still have tree mortality from drought and bark beetles. And this is one such area on Pine Mountain. This is mostly Jeffrey pine that you see here. In fact, I think this is all Jeffrey pine that you see here. And you can see there's some nice big old trees that have died within the last few years, likely due to the big drought that we're still in, in large part. And this was a very open area. So I I can't stress this enough. Just because a forest is open does not mean that it won't also be subject to natural disturbances, especially drought, which is often in tandem with bark beetles. I'm not saying this is a bad thing. These big snags are going to be really crucial components of habitat here, for various species, and I'll talk a little bit more about that in a bit. But don't get this idea that just because a forest has been opened up, um, that it is just automatically, it's like way more resilient. These forests are already quite resilient, and that is one of the problems that I talk about a lot is that people confuse resistance with resilience. So the Forest Service is saying they want resilient forests. Resilience means that this ecosystem can experience some big disturbance and kind of change potentially dramatically, but then can reform and approach something that's similar to what it was before that disturbance. That's resilience. Resistance would be that it doesn't change very much despite that disturbance. Hopefully that makes sense. So what we want really is resistant communities like homes. We want resistance in homes so they don't burn. And resilience is something that already exists in a lot of these ecosystems out on the landscape. Um, and one of the things that I've certainly spent a lot of time documenting over the years is post-fire forest conditions. And the cool thing about fire is that it a lot of this work that the Forest Service is saying that they want or need to do, like in terms of thinning, fire does that for free, and it does it really pretty well. Here's an area. Where is this? Grade Valley. Yeah, this is in the project area actually. This is along Grade Valley Road. I think that would be off to the left or somewhere behind me. This area burned in the day fire back in 2006. Um, and we got some cool stuff going on here. I mean, a lot of survival here, certainly a lot of mortality that happened because of the fire, but I would say that this is natural thinning that's sort of happened here. And we've got some good understory redevelopment, a lot of Great Basin sagebrush, and depending on the time of year, you probably see a lot of wildflowers. There's probably some like wallflower coming up here and there. And I was just out here recently and saw a lot of lupins and other things. But yeah, fire can open these forests up on its own. This is another place. This is along Fishbowls Trail. Same fire, same sort of situation. A lot of cool nitrogen fixing shrubs coming up, whitethorn, ceanothus, and you can see we've got nice sort of heterogeneous forest structure here. Here's another area. I'm just going to show you. I'm going to show you photos because I think photos are really, really valuable and useful. And yes, this webinar will be available to view later for whoever's asking in the chat. This is Alamo Mountain, same fire, day fire. And the reason I bring this fire up a lot is because it burned. It's one of the larger fires that actually burned conifer forest. This was mixed conifer, mostly Jeffrey pine, but definitely uh, some white fir and a lot of black oak in here. And you can see this is in the fall, and almost all of these black oaks that were burned in the fire 14 years ago, they resprouted and they're doing all right. They're doing pretty well, I would say. And you've got nice forest structure here that was created by fire rather than thinning. And just so you know, those are big cone Douglas firs up there. They are really weird and awesome. They're one of my favorite tree species in the world, and I can talk about those later. But they do operate a little differently than here. Everything you see burned in the day fire. The big cone Douglas fir, they're a little different than these other pines and firs. They can resprout from their branches, kind of like redwoods. So that's pretty cool. Here's another area, day fire, a little bit more intensely burned here. This would be like a moderate or high severity patch right here, but mostly moderate, low severity. This is on Seward Mountain, fairly close to Alamo Mountain. I believe this is in the project area. Actually, this is in the project area. I think this is also in the project area. It's really weird to me to see most of Alamo Mountain included in the project area, even though it did just burn in 2006 and is doing really well. So I just talked about like open forest conditions and, you know, made a case for like the fact that there is a lot of open forest in the Los Padres National Forest, and there's a lot of heterogeneity on the landscape. But what I don't want to do is diminish the importance of denser forest or small trees, because that's what people are often like, well, you got to get rid of small trees because those are what can carry fire up into the taller trees. And there's a lot of debate about this in the scientific literature, but there is really good evidence that historically, when you look back at the 1800s, um, small trees were a much more dominant part of forest composition than people realize. This study found that overall in Western North America, when they were looking at dry forests, so we're talking dry ponderosa or Jeffrey pine forest and mixed conifer forest, small trees made up 61% of trees total. So they were much more dominant than people probably think. And this is from a really cool paper that is about why forests have always had a lot of small trees, and that's just because it's a way to be resilient as a forest. Um, you know, some of the smaller trees, they come up during different conditions. So like right now, we have trees that have been coming up during the era of intense climate change. Those are probably the trees that are going to survive long term as things get drier and hotter. The trees that came up during the 1700s, during the Little Ice Age, probably not going to do as well under climate change, right? And so it's important to have these small trees on the landscape. And when we go out and we remove them, and you know, there's not like the Forest Service is out there doing genetics testing to see which trees might be the best suited for these areas, you know, under climate change. We could be reducing long-term resilience in a lot of cases. The other thing that has been debated, but I think there's more and more agreement on this. You wouldn't know that based on the way you read, you know, like media articles are often reported. But in the scientific literature, what has been found is that most of these forest types, so particularly mixed conifer and dry like ponderosa pine and Jeffrey pine forest, they have been experiencing for many millennia and continue to experience what we call mixed severity fire. So when you think about a fire coming through a forest, most people probably they could imagine one or two things. Like they'll think of good fire as like fire that only comes through the bottom, you know, the understory, and it kills everything in the understory, but it leaves all the mature trees, right? People will often call that good fire. It's low severity fire. And what they'll call bad fire is when fire comes through and it kills like most or all of the trees in an area. The problem with that dichotomy is that it it's not good or bad. That fire just like it is, and it can create unique conditions after the fire in both of those situations. And those conditions can be really important to different assemblages of species. So this is what mixed severity fire looks like, and it is predominantly what we see. And in fact, in any given major fire in like in California, most of the area burns at low to moderate severity in forest. And that's what you're seeing here. Low, a lot of tree survival. You can see a lot of green canopies here. This is 1 year after the rim fire up by Yosemite. I think this is in the Stanislaus National Forest though. This is moderate severity, so you got a little bit more of a mix of, you know, a lot of dead trees, but a lot of surviving ones as well. And then this is high severity, where you can see this patch where it's just like 100% tree mortality. People would look at that and say that's bad fire, and they'd look at this and say, well, that's good fire. And again, all of this is just mixed severity fire, and it's important regardless of the fire type here. And one of the ways we know this is that there have been a lot of studies, especially related to birds and how birds deal with mixed severity fire. And what researchers have found for the last couple of decades is that some birds you really only find in areas that burn at high or moderate severity. Other birds you may only find in unburned forest, and some birds you only find in dense unburned forest. So you need all of these conditions on the landscape in order to foster this biodiversity. This is a really cool study. If you ever want to read, feel free to reach out anytime. If you want to read some of these studies, I can send these to you. There have been a lot since this one, but this is just a really cool figure. I love this one. But you can see hairy woodpecker. And in some of my presentations, I show this, and then I have a photo of a hairy woodpecker foraging on a dead tree that was killed by the rim fire in a high severity fire patch, which I always think is cool because that's where I tend to see these. They really like these high severity fire areas. There are certain owls that prefer, they are more common in higher severity areas than in low severity areas. But then there are other owl species that really like low severity fire areas. Bees, this is a really cool one. So I think we get hyper focused on some species, like certain types of birds, maybe certain types of mammals too. But we forget about insects. And what a lot of studies have found actually is that you get these really cool increases in biodiversity in terms of like bee diversity and other pollinators with increasing severity. And that has a lot to do with the fact that as you increase severity, usually you see a lot more in terms of like fire following wildflowers, herbaceous plants, shrubs that often have a lot of flowers on them that will come up for several years after a fire. And the bees are really, really positively impacted by that. Bats are another one where we see some bats prefer this really dense canopy cover. These are clutter adapted bats, basically. I forget what species this is. I probably should have put these species on here. This is from a cool paper from a couple of years ago. But some bats, they like these really open conditions, and they like the open fire severity areas, right? The higher severity areas. And the other thing that I think the Forest Service talks about a lot is like that these areas, when they do burn at high severity, they don't regenerate. Like trees aren't coming back up from seed. And here's just an example area. This is the pine fire. This is on Pine Mountain, but out in the Sespe Wilderness. This is a fire that happened in 2016. And this is about 5 years post-fire in a little high severity fire patch. And what's cool about this, it's like nobody planted these. These are coming up naturally from seed. And every species of conifer that you can find in this area is represented here. So you got sugar pine, you got Jeffrey pine, you've got white fir. There's a white fir coming up right here. And there's a lot of seedlings here. And in these areas where it's really dry, like Pine Mountain especially, you'll notice that there's not a lot going on in the understory just in general. This is a very dry area. It doesn't get a lot of rainfall. The soil is a little bit unique. These are the places where it will take some time for these forests to regrow, but this is part of the natural succession process. But it does happen. And of course, with climate change, we will see some places, trees just aren't going to be able to survive regardless of whether or not fire happens or not. It's just, it has to do with temperature and rainfall. Lack of precipitation is probably what is going to do some areas in, and they're going to become more dominated by hardwoods and shrubs, which I look at as like, that's a form of adaptation, for these ecosystems. And the real root cause of those issues, though, is climate change. And that's why we have to be addressing climate change very, very seriously. Here's another area. This is the Alamo Mountain area. Once again, I just wanted to show you these black oaks one more time because they're so cool. So this happened 14 years before this fire, and you can still see like all of the snags are still standing. These trees survived. They didn't actually die in the fire. They were top killed. That's what people call it when this above ground biomass dies, but they actually re-sprouted from their base. And most of these survived in that way, which is pretty neat. This is another cool place in Southern California. This is in the San Bernardino Mountains. This was from last fall. And this was in a pretty big fire called the Butler 2 fire. And I'm standing in the largest high severity patch. It's really quite a ways until you encounter a tree that actually survived, a conifer that survived. So we're out here in this patch, and what it looks like is, okay, well, there's a lot of willows that have come up. That's great. There's a lot of shrubs. That's, I guess, okay. what the Forest Service would tell you is like, well, yeah, look, the shrubs have replaced the conifers, and there's no conifers coming up um, because the shrubs are out competing them. But here's the thing. Uh, and I've walked through this area, bushwhacked through this area, and it's tough. It's not easy. It's not easy. One of my coworkers who may be in the audience, she was with me for part of this, and she can tell you as well, Rebecca, if you're out there, um, we had some fun out in this place. But what we found was a lot of conifers. All these arrows are pointing to a conifer, mostly Jeffrey pine, but definitely some white fir and incense cedar as well. And they're not easy to see from a distance. These are just the ones actually that I can see just by looking at this photo. And a lot of them are going to be still underneath the canopy of the shrubs. And the shrubs are actually acting as a nurse plant for these. You know, these are probably benefiting not just from the fact that most of the shrubs that you see here are nitrogen fixing shrubs. These are mostly ceanothus. So they're putting nitrogen back in the soil, which is good for these conifers. But they're also providing the right mix of shade and sunlight that they may need to survive. Rebecca, you are there. Okay, cool. Yeah, it's amazing. But if you look at it from a distance, you may not know what's actually going on. And it's really easy to miss that. And there have been some really cool studies that, involve going out there and actually looking really intently for these seedlings and saplings. And they're definitely out there. It takes time though. It takes time. It's not something that happens overnight. And just again, what you're seeing is what I pointed at in that last one was just what I could see from that photo. But there are a lot that are still in the shrub canopy, and they're just really hard to see unless you kind of stumble upon them. And I've seen them in places. I mean, just it's really incredible. And I can talk more about that later. But here's the rimfire. So this now we're outside of Southern California, but I just wanted to show you like precipitation. Average precipitation does matter quite a bit for this. So here's an area that similar forest type, but it's a lot wetter up here. This is up in the Sierra Nevada, close to Yosemite. And you can see this is only 7 years post-fire, and there's a lot of regeneration. This is also in a massive high severity fire patch. You can see the black oaks survived, they've resprouted. There's a lot of cool shrubs that have come up, and there's a lot of conifer saplings like everywhere you look in it, and you can walk deep into this patch and it all looks the same. So, and this isn't planted, this wasn't like managed after the fire, this was just sort of left to its own devices. So this is part of the natural forest succession cycle that happens in these areas. And it's not just conifer forest. And in fact, it's actually more pronounced in other vegetation types. So like oak woodlands, for example. So this is a little kind of oak woodlandy sort of area. This is more like a riparian woodland. This is right after the Thomas fire. This is 2 months after the fire. This is the exact same area. This is like what, 2 years after 2 years after that, almost 2 years after that. These coast live oaks, they all survived. They've resprouted either from their base or up in their branches. This is called epicormic sprouting. And a lot of the sycamores also survive. They can resprout as well. And this is what I see most of the time when I'm out in these types of areas that are burned. This is from the cave fire that happened back in 2019 in the Santa Barbara front country. This was a coast live oak that right after the fire looked completely dead. It was blackened from head to toe, and it has redeveloped its canopy to a large extent since then. And this is just another example of some oak woodland in, where is this? This is probably the North Fork Matilahaw Canyon area, I think. This is before the Thomas fire, and this is right after. So this is like 5 months after the fire, and it looks like this whole oak woodland is just completely dead, right? It's just destroyed. That's what people would think when they see this. And this is what it looks like 4 years after the fire. And you can see there's a lot of really good canopy redevelopment. Look at all these big shadows that are being cast from the trees. Oak woodlands are incredibly resilient, and I think people don't give them enough credit for just how well they can bounce back after high severity fire. And we see it in other hardwoods as well, like bay laurels. The most growth I've ever seen on trees after fire is bay laurels. It's remarkable. This is my partner, Gabby. She's not like 10 feet tall. She's like average height. So just look at these bay laurels. It's just really amazing. This is all regrowth. They survived. This is all basal resprouting. But this is just in 4 years, and they've already put up 20 plus feet of growth. Okay, now in Chaparral, they can be a little different than like in forested areas. So what we know about chaparral is that they periodically, areas that are dominated by shrubs that we would call collectively chaparral here in our area in the Mediterranean climate, especially here along the coast, um, those periodically burn in very large fires that are usually driven by Santa Ana winds or other extreme wind conditions. So there's this cool study from 1999 that they looked at 560 years of sediments in like a sediment core in the Santa Barbara Basin. And what they were looking for were like these layers of charcoal. And for the first 100 years, they had data that they could actually correlate these charcoal layers with large fires that occurred in like the Santa Barbara Ranger District area, basically. And so then they basically come up with this correlation, and then they can go back in time. And when they see that same amount or that threshold gets crossed with these charcoal deposits, they know that that was very likely a fire that was larger than 50,000 acres. And so you can look going back almost 600 years, right? 50,000 plus acre fires have been occurring, usually once every couple of decades, somewhere on the landscape, not in the same spot, just somewhere on the landscape. And this this is just a very strong pattern, and it's continued to happen. And it may get more, these Santa Ana wind conditions they may get more frequent with climate change, but what has definitely gotten more frequent is ignitions that occur under these conditions. So we may see continued large fires that occur under Santa Ana wind conditions, but it's because mostly human caused ignitions. And I got to say, a lot of these are probably human caused ignitions as well, accidental, even going back pre-colonization. There's so little synchronicity between lightning strike season, like lightning season in the Santa Barbara area, and Santa Ana wind season. And it's very likely that people have always been accidentally starting fires under these more extreme weather conditions, or they started a fire and then it kind of hung around under mild weather conditions and then got picked up by some big winds or something. So this is what it looks like though in Chaparral if everything's going all right. So here, this is old growth, mature chaparral right after 1 week after the cave fire. This is a really, really amazing place, like the biggest toyons I've ever seen. And I think this hadn't burned in 80 some odd years, something like that. And this is what it looked like 5 months after. A lot of fire follower activity. This is giant Phacelia. But here's another example. And so this is you're seeing the same scene, just like one half. Just imagine that this, 1 month after the fire looked exactly like this. But this is 16 months after the fire. And this is normal. Like people see this and they really freak out, but this is exactly how chaparral burns. And this is what it is adapted to. It is this high intensity, high severity. And severity is not even the right term because a lot of these shrubs actually didn't even die. They've been able to resprout. That's what you're seeing a lot of here. But you can also see a lot of seedlings coming up in between those resprouting shrubs. And this is another area in the cave fire. I did a lot of work for a couple of years in the cave fire, photo documenting regrowth. And this is sort of a little slice of the scene, but at different times after the fire. And so you can see it looks really good. 17 months after the fire, a lot of really good, most of the shrubs that could resprout, they did. But there's a lot of ceanothus, manzanitas that are coming up in the spaces in between from seed. Now, in contrast, thank you in the chat. In contrast, this is the fuel break right next to that area. And this is actually where the fire started. The cave fire started along Camino Cielo, like in the Camino Cielo fuel break. And then it burned down into this area. So this is exactly what it looked like before the fire. It burned, and you can tell because a lot of these shrubs actually did burn. And you can see that this is this is like 5 months after the fire. All of that non-native invasive grass, this is all wild oats, and there's some mustard mixed in here as well, is already back. It's already growing back and ready to burn again, right? And then this area is going through this really cool process of regrowth over here. I would not call this a healthy ecosystem. This one is. I think this is perfectly within its normal range of variability and is quite healthy. But this is a serious problem here for a lot of different reasons. Now, one of the things, and to the Forest Service's credit, they did mention this a little bit in their proposal, is that we do have this problem happening in Southern California where if not enough time occurs between fires in Chaparral, you can lose a lot of species. They simply will not, they will not come back up from seed. And this is a really good example. It's a small example, but it's a really good one. This area that you see, everything you see here burned in either the Hezecita fire or the Tea fire. This was either in 2008 or 2009. And what was coming up after that in the years since was mostly a couple different types of ceanothus. There's some green bark ceanothus back here, but a lot of this was big pod ceanothus. And that's what all these little individual stems are. They were coming up from seed because that's the only way this species comes up after fire. Is it doesn't resprout, it only repopulates an area from seed. And that seed very specifically only germinates when it experiences high heat in the soil. And so that's exactly what happened when either the Tea fire or the Hezecita fire, I don't know exactly which one it was right in this exact spot, but they burned all the adult ceanothus that were there, and then it stimulated the seed germination. So that's what you're seeing is all these individuals came up from individual seeds. Now, flash forward to 2017, less than 10 years later, this little patch here burned again in the Thomas fire. And now we're 3 years after the Thomas fire, and you can see there are no ceanothus seedlings coming up in this area, right? And they're close to like these places that do have ceanothus that are producing seed at this point, but they're not. It's not like it just comes up again. The seed will only germinate with fire, but if the fire is too frequent, then this is what happens, and you will see these areas. What generally happens in these places is that non-native grasses and weeds start to become more dominant in these places. So this is a serious problem. This is what we call type conversion. This is the sort of first stage of it right here. And this is happening on a grander scale in some places, more so than others. But this is an example of a place where there are some concerns, like the Alisol fire. If anyone remembers that from last year, it reburned a big chunk of the Sherpa fire. So this is all mostly Chaparral, and this orange part here, this reburned. So this was like 5-year-old vegetation here in this spot right here, and it reburned. And then this area over here, it reburned as well, but this was from 2004. Either way, I would expect that we're probably going to have some certain species kind of start to disappear from these areas. But I have not been out into these. This is really hard to get to and check out, so I need to do that at some point. But we don't want to be seeing this. The problem is, what the Forest Service is proposing to do with this project isn't going to stop this from happening. They talk about it being a concern, but the only way that we can really deal with that is by cracking down on unplanned, human-caused ignitions, especially those that occur under more extreme weather conditions. And those often are from like power line ignitions. And in fact, I just got to say, the Forest Service, part of their project that they're proposing right now would have this fuel break right here. And that would have done basically nothing in this fire, because the fire started right here where their fuel break would have been if it had been created before this fire. The ignition happened along this road up here, and then sundowner winds drove it within just like a few hours all the way to the ocean. That's what we tend to see with these types of fires, and we see it time and time and time again, is that these fuel breaks fail when it matters most under those extreme weather conditions. So like, look at this. This is the Camino Cielo fuel break. I showed a slide early on of this. This is Winchester Canyon Gun Club and Lizard's Mouth over here. So you can see this fuel break stretches all the way along the crest of the Santa Ynez Mountains here. And this is before the Whittier fire. Actually, this says after. It should say before. But this is before the Whittier fire. And then this is after. This is that fire occurred in 2017. The fire started over here, burned up to this ridgeline, burned right over it. And then what actually stopped the fire mostly was, I think some people would say, well, look, it stopped at the Sherpa fire area. And I would say, yeah, sure. It also stopped at these, like along a lot of this line here, which didn't have some recent burn that it was running into. It just stopped because it experienced different wind conditions starting to push. It's like you get these breezes coming off the ocean and pushing the fire kind of back into itself. And it's also hitting these like deeply incised canyons that are sort of running east to west. So you got these moist north slopes that it's encountering. There's all sorts of topographic reasons why the fire does what it does. But what I can say is that this fuel break did not keep this fire from crossing the mountains. And it could have, very well, if sundowner winds had been driving it, gone all the way to Goleta or so. Same thing. This is the Thomas Fire area. This is near Ojai. Ojai's this way. And these are a series of fuel breaks. This is just one part of a very large series of fuel breaks actually in this region. And this was before the Thomas Fire. This is after. You can see that the fire went right through all these fuel breaks. I don't know if, the thing about fuel breaks is that they're only useful if firefighters are present and are doing suppression activities. But you're not going to put firefighters in front of a really fast moving fire. And even if firefighters are present, fire, can still go over these fuel breaks because embers can travel very far distances. I've talked a lot about this in previous presentations, and I can talk a little bit more about it, if people want to chat about like why do these not work. But the answer is embers. You can have long range spotting, especially under those extreme weather conditions. And there's just really not anything you can do on the landscape that will change how that fire moves across the landscape if it's being driven by 60-mile-per-hour winds, and humidity down in the teens, or less than 10%. So this is West Cuesta Ridge. This is up by Slow. This is 1963. This is before a big fuel break was put in along West Cuesta Ridge. I've actually talked to some people who tried to fight this project back then, but it happened. This is the fuel break in 1968. So this is after it was implemented. And this is what it looked like in 1989, still there. You can still see it along the ridge line here. And then in 1994, it's really hard to tell, but everything you see burned in the Highway 41 fire went right over this fuel break. And that fuel break is very similar to what happened with the Whittier fire. It sort of bisects the fire and didn't really change the result of that fire. Someone asked, can't fire breaks be helpful for less powerful fires? So, there's a difference between fire breaks and fuel breaks. I'm sure you mean the fuel breaks that we're talking about here. Fire breaks are very specifically like fire lines. Those are usually you're getting rid of all the vegetation down to mineral, like bare earth, bare soil. These fuel breaks are more like they're type converting from one vegetation type to another. They often become fire breaks. They often have bulldozers that will go up and down these fuel breaks when a fire does break out. And yeah, they can be useful under less extreme conditions, but those aren't the conditions under which the vast majority of fires that cause the most acreage burned each year or the most damage to communities burn. So the way I think about it, and the Forest Service even talks about this in their project proposal, is they say, we expect this to work up until like the 90th percentile of weather conditions. Those aren't the conditions you have to really worry about. It's that 95th percentile and up. That's when most of our largest wildfires and most destructive fires occur. So these aren't working when it matters most. That's what I mean when I say that. It's kind of like if we were only prepping buildings to be able to withstand 2.0 earthquakes and below. That's most of the earthquakes, but it's not the ones that cause the most damage. We've got to be thinking about what can we do to protect communities and people during those extreme weather events. And what we've seen over and over is that it's not this type of backcountry vegetation removal. What really helps is focusing on homes themselves, and focusing suppression activities right there next to homes and within communities. And we see this, it's not just in Chaparral, we see it in these thinned areas too. Like this is the Caldor fire from last year. And it started over here, burned right through these areas that have been commercially thinned, burned down most of the town of Grizzly Flats, and then went on all the way up to South Lake Tahoe almost. And you can see a lot of commercially thinned areas that burned at high severity. This was just a big wind-driven run, and the fire burned at mostly high severity because that's what the weather was dictating at the time. It didn't really have much to do with the forest conditions themselves. This is another one. This is the North Complex. This was, I think, the most destructive fire in 2020. It wasn't the largest, but it was the one that caused the most home loss, I believe, and maybe even the most fatalities. And that's because it burned down most of this town of Berry Creek. This fire started as two fires, eventually merged, and then they weren't really doing much. But what actually happened was this big cold front came through. And I don't remember how fast, I think it was like 50-mile-per-hour winds or something like that, 45 to 50-mile-per-hour winds, blew it within 24 hours down to Berry Creek. And it went through prescribed burned areas, it went through thinned areas, it went through a lot of these like private commercial logging lands. None of that stopped the fire. And what would have really helped Berry Creek would have been more community focused efforts, home hardening, defensible space, having suppression efforts really focused there. Because when it comes down to it, when you have these really extreme weather conditions, it doesn't matter what has happened out here on the landscape. What matters is what we've done inside our communities. This is another one. This is the Dixie Fire. This is from a paper. Was this from a paper? What did I made this for something? I can't remember. But you can see a lot of management on the landscape, a lot of forest management that did not stop the fire from becoming one of the largest on record. I have written a couple papers about this year, a couple papers that I've published. I'm happy to send these to you if you're interested. Just let me know. In terms of fuel breaks, again, the scientific literature also, this is not just like anecdotal information that I'm giving you, that is some of what I'm showing you. But there are papers about this, and one that came out in 2011, they concluded like constructing fuel breaks in remote backcountry locations will do little to save homes during a wildfire. These same authors have found that really beyond 100 feet from a home, if you're manipulating vegetation beyond 100 feet from a home, it's not going to really do much to protect that home. And what I did to just really drive this point home here is that, let me see here. Yeah, so I took this really cool data set from Microsoft. They actually used AI to find every single structure on the landscape. So a lot of these structures that are in this data set, they can include like sheds and barns and campground bathrooms and stuff. But regardless, I took every single structure and I drew a 0.5 mile buffer around it. And I wanted to see how much of the project area actually falls within this buffer, this 5-mile buffer, or 0.5 mile buffer. And again, 0.5 miles out from a house, it's not going to do much anyway to protect a home. But I'm just looking at like, let's just conservatively, like how like could you say that what percentage of this project is really truly in the wildland urban interface? And again, a lot of this I would not necessarily call the wildland urban interface. It's more like just rural areas, like scattered ranch houses and stuff. But only 22% of the entire project area is even within 0.5 miles of a structure. That is not a lot, for a project that is one of the main goals is to protect communities. This is not what we like to see. There's a lot of remote backcountry vegetation removal. And that's not going to be very helpful. Okay, so I know I'm going a little slower than I meant to, and I apologize. This will be available if you guys want to, watch it later. But dead and dying trees. What about bark beetles and disease? I'll just say that all the bark beetles that we're dealing with in Los Padres, when we're talking about conifer forest, they're all native. They've been co-evolving with these forests for millions of years. They're important sources of mortality in these forests. They actually help maintain ecosystem, health in these areas. There have been a lot of studies that have found that bark beetle, even really large bark beetle outbreaks, don't cause increased risks in fire severity. We even see that in a lot of cases, it reduces fire severity in subsequent fire. That's what this paper found. You can see this, time since the bark beetle outbreak, fire severity actually decreased. There's also some really cool research that's been done more recently that's found that bark beetles may be selecting these forests. They're basically selecting for trees that are better suited for climate change. So they're preferentially attacking trees that are genetically distinct because they came up under different climatic conditions and are weaker under these warmer, drier conditions. And these bark beetles may be helping these forests adapt to climate change in ways we still don't fully understand. And then the other thing is, I think people just really don't understand the value of dead trees. They're incredibly important. They're like ecological powerhouses on the landscape. And there's some really cool papers. Again, I'm happy to send you all these papers if you want to get in touch with me. But dead trees are used as granaries by acorn woodpeckers. They are really important for woodpecker nesting. So these are nest cavities that you see. There's like 3 of them here. This is on Takuya Ridge and a Jeffrey pine snag. Those cavities, once the woodpecker gets done nesting in them, then these secondary cavity nesters go in and use them. This is a violet green swallow feeding her chicks. Actually, this is a male. It's a male violet green swallow feeding his chicks that are down in this old woodpecker nest cavity that's in this really cool snag up on on Pine Mountain. Snag, that's another term for a standing dead tree. These are condors. Condors are famous for their preference for roosting in dead trees and standing snags. And when these snags fall, they become logs or downed woody debris, which are incredibly important to a bunch of different small mammals and reptiles and amphibians, which I know sounds weird, but like salamanders and lizards and snakes, they really value this habitat, but so do like chipmunks and other small mammals. They also provide important habitat for different mushrooms. You know, people don't talk about fungi very often, but they are important parts of this ecosystem as well. And you have to have dead wood in these ecosystems in order to support these populations of fungi. Also moss, all sorts of different things utilize downed wood. So it's really important. And just to give you a sense of like how much tree mortality have we had in the Los Padres National Forest, mostly from bark beetles. This is from a data set that the Forest Service has been creating for the last, since 2014. They've been doing these flyovers of most of the state, and they're actually counting the number of dead trees while they're in this little plane. And they've made these data sets each year. And what I did is I took each year's data set, and then I sort of layered them on top of each other and combined them so that what you're seeing is the cumulative tree mortality. So there is some mortality up here. Most of it in this northeastern part of the Los Padres, it's like background mortality. There's no real sign of like major bark beetle activity, just like normal standard bark beetle activity. There's some little patches here and there. This is like, as an example though, this is what part of the Sierra Nevada looks like. This is up closer, this is Yosemite. So like you can see, this is where, you know, when people think about these big bark beetle outbreaks, it's been mostly in the Sierra Nevada. So that's just to give you an idea, like we're not experiencing some huge outbreak. And then, you know, maybe the Forest Service would say like, okay, well, we could, you know, experience an outbreak. But what most studies have found, they don't really report this. And I'm working on a paper right now that actually is getting at this issue, which is they tend to, when they do thinning to prevent bark beetle mortality, they usually end up killing a lot more trees than would have been killed by bark beetles in the first place. And so like, here's an example. This is one of the most frequently cited papers. And what they report are just these little green parts of this bar chart. And they basically show that in their high intensity thinning, that's where there was a really low mortality afterwards from bark beetles. And they show that there was a lot more mortality in the unthinned areas. What they don't talk about is that they had to kill hundreds of trees per hectare in order to prevent this, you know, like, I don't know, it was like 13 trees per hectare from dying or something. They had to kill hundreds. And so what you see is that the cumulative mortality is almost always higher in the thinned areas than it is in the unthinned areas. And again, the bark beetles are out there. They're thinning the forest for free. They're doing the work, you know, for us here. And same with drought. This is from a paper last year, and you can see all conifers. So pay attention to this one. This is basal area. This is showing you basically tree biomass. What they found, they don't really talk about, but tree biomass was still significantly higher in unthinned control units compared to the thinned areas after the big drought event that we had during the 2010s. So you tend to have more trees and more biomass after these natural disturbances, even if you leave them alone. And one thing that I think people like, when you think about those gnarly photos of like, it seems like every single tree that you're looking at just was killed by a bark beetle. A lot of those are from plantations in the Sierra Nevada. This, like, you could draw the outline of this plantation based on the dead canopies here from a bark beetle outbreak. This was in 2017, I want to say, like right in the middle of the big bark beetle outbreak in the Sierra Nevada. And these plantations are just, this is not resistant at all, because they're usually one species and they're from the same genetic stock. And, you know, they may have been planted back in the mid-century. They're not, you know, if they have any weakness to these bark beetle attacks, most of them will, right? So just remember that when you see those photos, a lot of times it's plantations. Gosh, I've got so much more. I told you I was just going to scratch the surface. I'm trying to think of how much more I want to, I'm going to get to the last thing because I think this is important. So what I was about to talk about carbon accounting and stuff, but we can talk about that later. So what's important with all this is, like, what is the Forest Service proposing in terms of the environmental review process? So this is a big crazy flow chart that I made to just, I don't remember why I made this in the first place, but it may give you an idea of like the different routes you can take as the Forest Service to approve a project. And the thing you have to ask first is like, are significant impacts likely? If if they are likely, then the first thing you would do is you would just go straight to developing an environmental impact statement. That's the most robust form of environmental review that you can do under the National Environmental Policy Act. And everything has to go through some sort of environmental review. A lot of things get categorically excluded so that they don't really go through a very intense review process. But if you're not sure if impacts are likely, then you can develop an environmental assessment, and that could tell you, well, okay, yeah, there are likely impacts. So then you would go back to starting this environmental impact statement process. I know this all sounds really confusing, but what is mind boggling in this case is that the Forest Service is saying they plan to prepare just one environmental assessment for all 235,000 acres of this project. And what that means is they're saying they don't, either they don't think that there will be significant impacts or that they're not sure that there will be. And I, there will definitely be significant impacts. I mean, there's no question that there will be significant impacts. Like the California Native Plant Society, they've been working on this as well. And what they did was they looked at just like rare, sensitive, threatened, and endangered plant species and which ones occurred in the project area. 95 different taxa, species, subspecies, varieties occur within the project area. And there are 530 some odd known occurrences of these plants. 12 of them, I think it was 12 of them, of these different species, more than 50% of all known occurrences are within this project area. So yeah, likely there are going to be significant impacts. And so it would make more sense to just go straight to an environmental impact statement, which is a more robust process and provides more opportunity for people to comment. Regardless, they will probably end up at this place where they're either issuing a decision, a decision notice or a record of decision, and then there will be an objection period. And if you want to object, on this project, this is a formal process. It can help avoid having to go to court, but you can get some changes made to a project. You have to submit a comment during this initial comment period. And that ends on the 28th, and we're trying to get it extended. So stay tuned if it's going to be extended. But if you haven't already, and I'll show you how here in a second. But I do just want to explain something. This is a 235,000 acre project. The Forest Service, the last time they did an EIS for a vegetation removal project, like for fire reasons, was in 2018. It was that Monterey Ranger District fuel break project I mentioned earlier. It was 542 acres total. And they did an EIS, an environmental impact statement. And now they're saying for a project 400 times larger that they just need to do an environmental assessment. It is mind boggling. I cannot stress this enough. So if you haven't commented already, highly recommend that you do that. You can easily do so. We have this website set up, lpfw.org/ERP. You can also go to the interactive map that we've created, ERP-map. It's just our website /ERP-map. And if you want to do that now, I know it's kind of late, but if people are still around, I haven't even checked. We still have quite a few people here. If you have questions and you want to look on the map and ask me stuff while you're looking, that would be great. But I'll take questions now. Sorry that it was a little bit slower than I meant for it to go. And again, I just barely scratched the surface on this. You can follow us on social media. You can follow me as well as ForestWatch on Instagram. I post a lot about this kind of stuff in terms of fire regrowth. I also do some stuff on Twitter now with mapping, and we are active on all of these platforms as well as ForestWatch. Okay, so that's it. Let's see what we have in terms of questions. Okay, let's see here. Looking for information to speak with others on the topic. So many people just say clearing is good. We have the science showing alternatives, right? Yes, there's a lot of science out there that shows that a lot of these types of activities that are being proposed are not only going to be ecologically damaging, but are also ineffective, again, under those more extreme weather conditions, especially, which are when most acres burn in any given year and when most homes and communities are damaged. So trying to think, maybe we can touch base afterward, and I can send you some information that you could share with others. Thanks for folks who are saying thank you. Appreciate it. Let's see here. I recall early LPNF publication linked fire and fire suppression with water availability. Gosh, there's so much debate on how water availability is affected by, um, like forest structure and thinning and all these things. Uh, I don't know. It's too complicated to go into right now. I could send you some stuff. There are some studies that have found, like, yeah, you get more water in some cases. Um, but now that I think about it, there's actually a really cool study that came out last year. I think it was last year, and they looked at the Illilouette Basin up in Yosemite National Park, and that was an area where they did managed wildfire, no thinning. They just, back in the 70s, they just started letting wildfires burn. This is managed wildfire, so it's not like they were just, they like watched it closely, but they would let wildfires burn, the natural ignitions like lightning strikes. And a lot of that area has burned a few times since the 70s. A lot of it hasn't burned since the 70s, though. Just understand that there's a lot of variability on the landscape. But what they found was, um, I think about 20%, or what was it, 16, or about 20% of the forest that was in that basin, um, is now more like shrub dominated. It had experienced like high severity fire. And so there's a lot of this mixture of habitats in that area. There's meadows, there's these big patches of like montane chaparral. And then there's also still areas that are forest. Some of the forest is open. A lot of the forest is still pretty dense. And so that, and that paper, I think what they found also is there was increased water availability in the streams. I have to go back and look at that, but they consider that a triple win is what I think they called it. And these are some of the folks that really, they really push the commercial thinning, even though they've published papers showing like you can do managed wildfire in these areas without having to go in and do all this thinning ahead of time. And it can create really unique habitat conditions. So, okay, I'm just kind of rambling now. Let's see here. Okay, so you want to look, so it's like Nancy, you want to look at the area above Goleta and Santa Barbara. Let me stop my screen. I'm gonna pull up. Let's see here. Bear with me for a second. I'm gonna go to our map. So I'll show you how this map works too, in case you guys want to know. I'm gonna share my screen again. There's my screen. There it is. Okay. So everybody should see this. Okay, so if you go to our map, this is again lpfw.org/ERP-map. That's obviously not the URL that you see up here. That's just a redirect link, but it'll get you there. You get this little sort of info splash screen, and this is the map. It's a little different than some of the maps I showed you earlier. I made those differently, but this one, everything in red is part of the project area. And if you zoom in enough, you'll start to also see like recreation sites, and you can toggle the layers. So like you can, oh, I forgot to mention like the condor. Yeah, there's so many things that I forgot to mention just because there's so much. I think it's 48 miles of the Condor Trail, which is would become a national scenic trail under the Central Coast Heritage Protection Act, is included in the project area. So that's a pretty big potential impact to the Condor National Scenic Trail, our proposed National Scenic Trail. And also some, let's see if I have it turned on. I think I do. Some wild and scenic rivers. So what you'll see like over here, this is the proposed wild and scenic Piru Creek portion, and a huge chunk of this is within the project area. This is really troubling. So I think, Nancy, though, you wanted to see the area near Santa Barbara and Goleta. And one thing I will say right off the bat, let me just make sure I can still see the chat in case people are talking here. Okay, so first of all, this is called an ecological restoration project. And one of the things I first noticed was like, I see a lot of straight lines, 90-degree angles, rectangles. That does not scream ecological restoration to me. That screams arbitrary human created boundaries. And that's exactly what you're seeing. These are little buffers they've made around every single private public land boundary. And it's like a lot of these, I mean, they have this, where would it be? That's San Roque. That's Cold Spring. Okay, look at this. It's like, this is up, this is Tunnel Trailhead. So this is Tunnel Trail. It does intersect the project area a little bit. Like what would be the point of having a fuel break here in this way? What they did was that this is like a buffer around a land boundary, and that land boundary is actually it's city-owned land, if I remember correctly. It's just I mean, it just makes no sense. A lot of this makes no sense, and a lot of these don't make any sense. I just again, it's so bizarre sometimes when I look at this. Okay, so yes, Nancy. Now, some of these areas are in what you would consider the wildland urban interface, and we have a lot less of an issue with those, obviously. And I've said this before, like we do not oppose every single thing in a project. What we're opposing here is the process that this project is going through. A single environmental assessment for all 235,000 acres, completely inadequate, and that is putting it mildly. But also just the sheer size and scope and the amount of backcountry, um, project areas that aren't anywhere near structures or communities. That's what we have a problem with. And there have been projects up in this area that we have not challenged. We have pushed for like good mitigation measures, but to protect nesting birds and things like that. But we don't oppose things that are within communities or right adjacent to them. But we do push for the adequate environmental review process to be followed. Okay, Marisa, you asked, in the event that this goes through, who will be getting the contract to do this work, and how much does the Forest Service project it will cost? So that's a great question. This is a huge project. It would not be done all at once. This would probably happen over many years. And what I think is really going on here is the Forest Service is trying to approve this big environmental assessment that is just going to cover the whole 235,000 acres so that they can then say later, like, look, we've already done the environmental review. Everything is shovel ready. So then when funding comes from Congress or there's grant opportunities, they can just really easily get those and start doing work immediately afterward. This whole process, though, this environmental assessment process is being funded, this is the crazy part, by PG&E, the utility company. They gave the Forest Service a $1.7 million grant to do the environmental review on this project. We are still trying to get documents related to that. It's very confusing and we're not sure what's going on, but that's why the Ojai Ranger District has been excluded from the project area. I look at that as largely a good thing, but the real reasoning is that PG&E doesn't have coverage here. This is SCE area. And so they were sort of limiting this potential work only to areas that PG&E, I guess, has coverage in. But a lot of this has nothing to do with their power lines, like where their power lines occur. And we would much rather see them spend their millions of dollars on fixing their infrastructure that keeps failing under extreme weather conditions. And we don't know, like it could be a bunch of different contractors, it could be multiple timber sales. There's just so much we don't know at this point. And this is why it's so alarming to see so much area and potential activities included under a single environmental review process. It's just completely inadequate. How much will it cost to change the outcome? I don't know. We'll have to, we'll have to see where all this goes, but yeah. And put a link to the map in the chat. Yes, I will do that. Let's do that real quick. I see your questions in the chat box or the Q&A box as well. Oh, thank you. Rebecca did that. Okay, so who else can we send letters in order to express our utter dismay and disapproval of this obscenity? Yes, thank you. And I appreciate your passion there. So elected officials, definitely. I would certainly reach out to your elected representative in Congress, your senator, your U.S. senators, and also, talk to your assembly members and state senators and urge them to submit their own letters urging the Forest Service to either let's restart all of this. Let's go back to the drawing board. Let's get rid of all these remote backcountry areas. Let's really think about what we're doing here. Or at the very least, we need to extend the comment period. We're asking for a 90-day extension so that we would have a full 120 days for a comment period on this. And we're also asking that the Forest Service prepare an EIS if they're going to continue on with this project as is. The very least, they have to do an EIS, an environmental impact statement. You can get in touch with us, myself, or Rebecca August, who's in the chat. You can reach out to us and we can help you with figuring out, what you can do to help more. Let's see here. I have some more questions. Downstream, what are the downstream sediment impacts of all this mechanical treatment, in quotes, both from equipment and from devegetation? How many fossil fuel emissions per acre during treatment, in addition to biological impacts on site? These impacts that affect the climate, downstream estuaries, et cetera, justify an EIS. Yes, we agree with you. We have never seen a project talk about emissions from the actual mechanical work that they would be doing. It's a great point. I don't know if we've ever brought that up in our comment letters. They really don't address carbon accounting in general. That was actually the whole sort of last part of my presentation, but I wanted to get to Q&A. But there have been plenty of studies that have found that these projects remove generally like 3 times as much carbon as they prevent from being emitted in a future fire. And there's a lot of misinformation about carbon emissions and wildfire in general. And I'm happy to talk about that. And I can be here as long as you guys want, to talk. I know people probably have to get back to work and other things, but these are all great questions you're bringing up, Eric. And yeah, we've seen certain, environmental assessments or even environmental impact statements where they try to address potential sediment issues. And yeah, it's usually not a very good job. And we always have things to say, but yeah, there are some potential serious impacts, especially again, I'm gonna zoom back in here. What are we doing here? This is Piru Creek out in the middle of the backcountry. This is a really remote area. I'm just gonna switch to the satellite view here. Talking about a fuel break along Piru Creek. It makes no sense. And the potential impacts are just massive there. You also ask a good question about microclimate in areas post-treatment. Yeah, there have been some studies, not as much as you would think, but there have been studies that have shown that you can get increased dryness, increased wind speeds, a lot more sunlight. These can have major impacts on microclimate. You can alter these areas so that they're not as suitable for certain types of wildlife and plants. But yeah, that's still a lot of work needs to be done on that. Okay, someone asked, if you're trying to do managed fires, don't fuel breaks make it safer for firefighters? Look, when I talk about managed wildfires, I guess let me put this a different way. There are a lot of fires every year in California, and let's think about I'm trying to think of what year it was. I had the stat. I think it was 2020. It was something like 0.5%. It's definitely less than 1% of all the fires that occurred in California accounted for like 98% of the acreage burned, something like that. I mean, it was some astronomical number. And most of those fires, and it's usually like a handful of fires, account for most of the acreage burned in a given year. It's because they are generally burning under more extreme weather conditions, those conditions under which fuel breaks don't do much good. And so in those conditions, the approach that we advocate is you can't do much to change the outcome of that fire other than try to focus on communities, do suppression right around communities, and focus on the homes themselves, put water on the homes, try to get people out of communities. That's really important. But those fires are going to move across the landscape however they're going to move across the landscape, and there's not much we can do about that. That can be managed wildfire. That can be where your management activities are focused, your suppression activities are focused right next to communities. And a fuel break right along the edge of a community, like next to a cluster of houses, where you're talking about like within hundreds of feet of homes, that can make a lot of sense. Out in the backcountry though, yeah, maybe it can help with suppressing some fire under really mild conditions that often what we see are those fires just sort of peter out on their own. We saw like with the pine fire, this was in 2016. This was, where am I? Let's see here. This is up here in this area. You can actually see it. So this is the pine fire area. You can see it looks not as dense as some of these areas around it. Burned in July, burned like 4,000 acres-ish. Mostly low, moderate severity, a couple patches of high severity, no fuel breaks anywhere around. They did some hand lines up here on this ridge, pretty minimal suppression activity. That was managed wildfire without fuel breaks. And that was out in a wilderness area. Under mild conditions, you don't necessarily need fuel breaks. So yeah, I hope I answered your question, but this stuff is pretty nuanced, I would say. How can we review and share your presentation with others that we are not able to, that weren't able to come today? We will have, we'll have our e-news will go out this week, hopefully tomorrow, and we'll include a link to this. We will put it on our website. We'll also have it on our YouTube channel, and we'll probably post some information about it on social media like Instagram and Twitter. So also, everyone who attended or who, even everyone who just signed up, we will send you an email later, and it will include a link and some other info. We should activate the Morro Bay National Estuary Program for comments on sediment concerns. Please do. Feel free to reach out to any groups that you know or are part of. We do have a group sign-on letter. If any of you are part of an organization, we have a sign-on letter that we're hoping to send later, like this evening, to the Forest Service, just asking for an extension for the comment period and asking that the Forest Service commit to preparing an environmental impact statement. So if you know anyone, please reach out to us, and we can send you the form. We have a Google form so that you can easily sign on to our letter. That's for organizations. So let's see what else. See your comments in the chat. Good times. Yeah, appreciate people being here and thanking us. I mean, we're just we're just doing what we do, and we're very passionate people here at ForestWatch. There's just a few of us, and but we have a lot of people behind us, right? We have a lot of supporters, a lot of members, a lot of board members. We work really, really hard and tirelessly on these issues. Everyone, Rebecca, Graciela, Jeff, everyone that I work with are just amazing people, and they work so hard on these things. And I know I'm here doing this presentation and talking to you folks, but they're doing so many other things as well. And it's a team effort. So really appreciate all of your support. Cool. Okay. Well, I think it looks like we don't have any more questions. One of the best presentations ever. Thank you. I don't know about that, but appreciate it. Okay. Well, I'm just going to hang out here. If anyone has any more questions, feel free to put them in the chat. If I'm probably going to maybe stop the recording. Let's see here. Yeah, I don't think I've missed any questions. Rebecca or Graciela or even Jeff, I don't know who all's there. Do you guys see any questions that I've missed? Again, I really just scratched the surface. So there's a lot more to this, and we have a lot of information on our website just about these things in general. And Graciela and I actually did an Instagram live the other day. I think that was last Friday, and that's on you can go find that on our Instagram really easily. And I think we covered mostly the same things here, but it was a little shorter and maybe more digestible for some folks. And you can always reach out to me. I am a little preoccupied with trying to put together our comment letters and stuff for this project, but I will try to get back to you with information as best I can. Yeah, there are a lot more visuals here on this presentation, and that's very helpful. We weren't able to do visuals for the Instagram live. Okay, well, I think that's it. I don't see any other questions. So thank you again to everyone. And please go, if you haven't already, submit a comment, lpfw.org/ERP. It's really, really easy to do. If you can change, like we put some text in there, but you can change that, and personalized messages are much more effective. So feel free to express your own personal concerns. If you can reference specific places that you're concerned about, that's always very, very effective. And yeah, just feel free to get in touch with us if you want to learn more about how you can help.